Hey everyone, I am the Bisso. I hope all of you are doing well. I'm a machine learning engineer and I'm passionate about backend development, microservices, and all the other nitty gritties that get involved. With my handful of experience, I have had conducted a couple of technical trainings since the past 1.5 years. I have written backend development codes, I have written machine learning models for some clients such as GitHub, Microsoft, and recently Meta, which was formerly known as Facebook. So, from my handful of experience, for this particular demonstration, I would like to choose Django for today's purpose of demonstration. My reason being, more often than not, Django is known as the backend development framework for perfectionists with timeline or a deadline, because Django comes battery packed with a couple of features, and within a short span of time we'll be able to create the most complex features that can possibly be done, right? So this will be a full stack demonstration wherein I will be using Django, Docker and Docker Compose for orchestrating the microservices. We'll create a couple of microservices using Redis, our backend development framework that will be Django, our database in Postgres, and we'll also use Nginx for routing. So, considering that this is going to be not this is going to be a 30 minutes demonstration, I'm going to assume that certain we can say prerequisites are already familiar with the audience. For example, Docker is known, Nginx is known, what is caching or basics of caching is known, and this video will be particularly about Django or the web development framework using Django. So we'll be using a backend framework, Django, or you can assume instead of Django, it can be Node.js, Golang, or any other framework that needs to be done. We have a database, we have cache management, we'll have a front end, and obviously a backend that is Django for our case, and we'll use Nginx for as a web server, right? So let's get started. Before we get started, actually, the agenda of today's demonstration will be to create a pet adoption website. The pet adoption websites provide two features. One that is, a web view or the front page wherein we should provide some details about, let's say we are an NGO and we want to list a couple of pets that needs help in terms of adoption, right? So we'll create a website wherein we'll a couple of pet campaigns or a couple of pet posters would go live, and we'll create an admin panel wherein a person should be a point of contact from the NGO, or a person who's authorized to make amendments to the website should be able to log in by using some secured credentials, and in a GUI or an intuitive interactive way they should be able to post a couple of pets, and the moment they post that, the same should be reflected in the main website. So we'll create a web view wherein people can register or see the pets that are up for adoption, and they will create a secure admin authentication panel wherein the admin should be easily able to add a new pet, provide some details, and just get going, make it as easy as possible in a authenticated manner, right? So let's jump directly into it. All right. So this is the GitHub repository that will be available to you, and you will have some boilerplate code to get started. Speaking of which, the first step that we need to do is we'll create a virtual environment, because anytime that you are creating working on a project in Python, make sure that you always create a virtual environment by default. This makes your code future proof, because basically an environment file is nothing less than C's in a point of time, right? So whatever versions of the packages that you're using will be tracked within it, and that lets you make sure that your project is reusable. So maybe a year down the line, a few years down the line, you turn up your project and it says, sorry, this is depreciated, this does not work, there has been a breaking backwards incompatible change. That sort of problems are solved by that. So let's create a virtual environment. The command to create a virtual environment is pretty straightforward. Making sure that Python is enabled installed on your system and available in your path. All you need to do is write Python 3 space -m. -m is basically a shorthand flag for module. So instead of directly going into the Python REPL, read, evaluate, print, loop, that Python REPL wherein you write inline Python code, instead of that, we'll pass a -m flag, which lets us directly invoke a module within Python. So the module we are interested in is venv, or short for virtual environment. And after that, we need to provide a name for the environment file, environment directory. So I'll name my directory as env. Now, upon creating this command, you can see on my just give me a second, I'm in the wrong directory. I'll go to cd. This directory is pet adoption, right? Now I'll run this command, python 3 m venv env. So the moment I run this code, you can see that in here, in the directory, in my project's root directory that you can see on the right hand side of the screen, the env folder was created with a couple of files inside it. If you dig deep, there's a library folder which comes with certain Python libraries that is required to run our code, and a binary folder which includes the binaries for Python and pip, which is package manager. So basically what env does is it creates your own isolated version of Python, from whatever Python version that was installed on your system. And on top of that, it makes it isolated, so none of your existing project packages or dependencies conflict. Now, having that done, having created a Python virtual environment, we are going to activate the environment to make sure that the further commands we run are going to be executed from within this environment binaries. So to do that, we need to write the source command, and we'll write env. Inside that, we just saw there's a folder called bin, and inside that there is a file called activate. Now, the moment we run it, since I have an interactive, actually the prompt that I'm using on my terminal is called omsjish. So the moment I run the source, you can see that the pet adoption environment is activated. In case you have a different terminal, you must be able to see something called env written at the beginning of your prompt. Somewhere you will see a prompt env. That's all we need to know. In case you are on a Windows machine, instead of bin, this would be scripts with a capital S for you. Windows has some history of bad naming convention. Let's just go with that, right? So now that we have created this, we are going to install a couple of basic libraries that we are going to need for today's project. So we'll write pip install Django REST framework, and we'll use my favorite text formatter called black. It's totally up to you. I totally understand if you don't want it. It's something that I normally use for all my projects. Or we can skip it for today because I already have a requirements.txt file present right here. All right, so now that we have installed Django in our environment, so Django is basically available on our package right now, within our library right now, a dependencies folder right now. If you want to make sure if it's installed or not, you can just write pip freeze. This will show you all the packages that are actually present in your system. So right now we have, since this is a vanilla environment that we just created, there are not a lot of unusable, unnecessary packages are all absent, and we just have what we need. Django REST framework, that's what we're going to use. And if you're thinking, definitely these dependencies are not enough to do everything that we are hoping to do for today. So that all the directories also don't need to be present right here, because we are going to use Docker to run our code. Now I'll just give you a quick overview why we are going to use Docker, because this demonstration is built on the assumption that Docker Compose, Redis is all clear to the audience as a prerequisite, right? So what Docker allows you to do, this is a sample Docker file which has comments literally in every command to help you understand it in an easier manner. All that Docker does, normally when you write a code and you publish it into a server, let me switch to explanation mode, right? So normally what happens when you are writing a code, which writing a backend server, basically anything that needs to run in remote server, what happens is, let's say for example, right now I'm developing my code in a Mac OS, right? I'm in Mac. So I develop my code here. You just saw that we created a virtual environment, or even if you don't, you have, although you should, Even if you don't, worst case scenario, the Python that you're using for your development is the or the Mac build of Python. So dependencies are different, maybe versions are different, maybe something is different. Always something is different. Keep that as a thumb rule, right? Now that I have developed my entire code and it's working, I've tested it out, its quality analysis passed. So now we have a server which is probably running on, let's say, GCP, because they have a couple of good services, or AWS if you're used to that. So now we have a GCP or AWS virtual machine, right? If you're in AWS, it's EC2, or in GCP, it's compute engine. So you have a virtual machine or a cloud instance, and now you want to run your code, which is tested and works fine, and you have quality analysis checked. You want to run that code on a remote server. Normally the process that you do is you SSH into that machine, right? You access its terminal and import your code, maybe using GitHub or GitHub server. And now that your code is present here, you run the code. Now the moment the code starts running, you will see a ton of bugs that come up. And obviously your code, which was previously working on your machine, is not working now. And it's a classical problem of computer science. Hey, it works on a machine, but it does not work here, and I have no idea. Now the reason is, most of more than 90% of the production ready web servers are Linux based, right? Because Linux is obviously hands down the best operating system for development production. And your development machine could be Mac, Windows, Ubuntu, any flavor of Linux or any version of Windows. And literally every time the versions will not match, there will be some conflicts. So how do you make sure that these things don't happen? And how do we make sure that our code is not just static piece of code, but rather it's something that's reusable, something that goes up and down without needing any configuration change for deployment or scalability. Now to solve all those problems, we have Docker. I'll try to draw a whale as best I can. So this is, let's say this is Docker. Now with Docker, you don't just ship your code, you ship the environment along with the code. This makes sure that the environment in which you built your code, the environment which is basically the operating system, the binaries, the complete environment in which your code has been built and compiled, is exactly same as the environment in which you are going to run your code for production. So this solves our first and the most crucial problem, or the most fundamental problem, that the operating system environment is changing when our code goes for production from development. And honestly, Docker solves a lot of other problems which we are probably not even going to realize, because it's that good, right? The beauty of a good solution is that it's effortless. It should not make your work difficult, but easier, right? So what Docker does is it ships the entire environment along with your code. And what you're seeing on my screen right now is basically a sample Docker file, which basically installs all the packages that we need. And in the starting, you can see that I've mentioned Python 3.9 Slim. So Python 3.9 Slim is basically an Alpine Debian based container with Python 3.9 installed in it. It's by official Python. It's the official Python Docker image. And inside that, I'm installing a couple of packages. And in here, you can see that I'm copying the requirements.txt file. Let me quickly search for that. So here you can see I'm copying the requirements.txt file from the host machine into the Docker container, or the virtual environment that is the Docker container. It's a lightweight VM sort of, you can say. And I'm installing all the packages that are mentioned inside it. Now, once the package is installed, once the dependencies are installed, basically we have a environment that is capable of running our code without any hiccups, because this is the same environment that we are going to develop in, right? And then there is a Docker Compose file, which is basically orchestrating all the services, because for today's project, we need a database. So I have already mentioned, for the sake of saving some time, I will not jump into details of what a Docker Compose does, but basically we require 4 microservices for today's project. And this Docker Compose makes sure that all those 4 microservices go up and down at once, so that we don't have to manage them separately. So there are 4 services that we're going to use today: a database, which is of type Postgres, and you can see that I'm passing certain things into its environment. Now let's quickly create an environment file where we can pass this credentials secretly, because there are some credentials cannot be are actually secured, confidential, or fragile, and you cannot share them directly into the container, because if it gets hacked, or if the data gets leaked, all of your secret confidential data, which provides access to your actual public data, or the user data, not the public data, sorry, the user data, can get breached. So to save that, these things are never directly provided into the container, but they are provided at runtime. So I'll get the get a couple of basic environment of variables that we're going to use. So what Docker Compose does, it will look for a file called .env, and it will get those values with this variable name. So you can see I've defined db password, db user, db database name, and db host. I'll explain what is host later, but these 3 things are pretty self-explanatory, right? These things directly go into the environment, and within the Postgres, we will create a new database with this particular name and this particular password. That's that. Then we have a backend server, which we are going to run in debug mode, because we are in development right now. Python buffers needs to be set to 1, because that is something that Docker needs in order to run a Python code, especially in Django. And these things are quite self-explanatory. We boot up our database with some credentials, and we pass the same credentials to the backend, so that it can securely connect to the database. And now here's a catch. Here's a catch. So now this is a Docker container, or Docker microservice is basically a virtual environment, or a virtual or lightweight operating system that running on your machine. And what happens is that, like, let's say this is your host machine, or the machine on which you're developing, your laptop, your PC, or whatever you're running your code on right now. Now, within that, we have a microservice called database. We have another microservice called the backend, and similarly we have 2 more, the Redis and Nginx microservice. I'll come to that later. 2 is enough to understand the concept for now. So your database, or the Postgres, by default it listens on a port called 543. And by using this particular line in the Docker Compose file, for example, for backend, I've mapped 8080 8080. So given the assumption that you guys are already aware about Docker Compose, 8080 is to 8080 basically means map the port 8080 of the container into port 8080 of the machine. So they are connected. Basically you can change them. The first one is for the container, and the next one is for the host machine. So now if we switch back to a diagram, database listens at port 5432, and the backend listens at port 8080. Now let's say the backend needs to connect to the database, definitely needs to connect. And these are microservices. They're independent of each other. Microservice is basically a form of data abstraction or data encapsulation, right? The backend does not know how the database stores data, but there is a particular port at which it can query that, hey, I need X, Y, Z. I need some candies start with the letter X. The backend does not care how the data is stored. The backend does not care how this query is resolved. All it knows, it can make a request to port 5432 and get the data that it wants using the secured credentials. Now, here's the catch. If the backend was not running in Docker container, let's say it was running on our machine directly without any Docker microservice. Let's say it was running without a microservice. It has a lot of problems, but for the sake of Assumption, let's say that it was running on our machine. This is the backend and this is the database. Now both of them are running on the same exact machine without any virtual container. So when I say to the backend that you can get your queries resolved at port 5432, so we directly connect to port 5432 and get our queries resolved. Now to this particular backend, if I tell to this backend that get your queries resolved at port 5432, it's going to connect to its port 5432. But think honestly, like think about it for a moment. There is nothing listening to port 5432 because this port 5432 is not port 5432 of the actual machine, but it's port 5432 of the container, right? It's within a virtual environment. So when it listens to port 5432, there is no one listening on the other end of it. There is no one here. It's just going to start listen there. It's going to, the connection is going to time out and it's going to be a big error, right? Now, to do that, we are creating something called a driver network in Docker Compose. If you look at the code in Docker Compose, there is something called network, and we are naming the network as pet adoption, and the driver is bridge. So this is something that Docker comes up with. Like it's something that actually solves a lot of problems. It's a rabbit hole if you start learning about it in depth. But here I'll give you a quick overview of it. Driver basically a network driver basically makes sure that the IPs of the containers is being managed by Docker, and instead of accessing the IPs, because there could be two instances of the database running, so how do you know which one to connect? Maybe this is for balancing the loadout. So what Docker does for you using network bridge is it tracks the IP for you, tracks the IPs of the containers. So now we can just connect to DB without using its IP. We can just mention the name DB, and Docker network will resolve the IP for us and connect us directly to this port 5432. Now that's what happening in this Docker Compose file. In DB host, I am just passing DB because DB is name of the service, and through that DB, the Docker network will resolve the IP for us, right? As simple as that. Now let's jump to the actual code. Okay, apart from that, there is one extra service that's running. Like Redis is basically for cache management. Let's ignore that for a while. And we have something here called Nginx reverse proxy. Now, an Nginx is basically a very highly performant web proxy server for backend for any backend server or any backend application, right? Now, or any backend framework. Now, what reverse proxy basically means is you want to, let's say your machine is listening at a particular port, and ideally when you are talking about a code in production, you don't want to nakedly expose all the available ports wherever your backend needs something. Rather, you create base URLs or base APIs, and then dispatch those APIs or decouple those APIs from the actual machine by using a reverse proxy in between, which takes care of some mundane jobs, like maybe authenticating for a token, or maybe detecting out the base URL and then guiding the network into particular calls, or maybe taking care of the HTTP headers. So in that case, reverse proxy is a highly performant system that we need. And since the reverse proxy is something that we are definitely going to use when our code goes to production, we can do that because this is a Docker virtual environment. You can basically create the actual production, simulate the actual production suite here, and use it according to your need. Now, to use this Nginx reverse proxy, we'll first create a folder called services in here, and then in you can actually name it anything. I like to name it services because that's one of the name of convenience, like it's a commonly followed practice. In here I'm going to copy a file and I'll explain it to you what it means. Right now, the file that I've copied is called nginx.configuration, and this is the default configuration that we are going to pass into our nginx file. So since this demonstration has an assumption that you already have an understanding of nginx, I'll just give an overview. Now, events is something that tells the nginx how many parallel connections can this particular server handle. After that, we have a block called http block, or in terms of nginx, this is called an http context. Inside here, we have a server context, which is what we are actually, which something that we actually care about. Now, HTTP requests are by default, directed into port 80. It's an IPv4 protocol, and HTTPS or HTTP secured hypertext transfer protocol secured is by default at port 443. Since this is a development server, we are going to listen to HTTP protocol. Then we name our server something. You can, for example, I have named it backend pet adoption. Clearly it's a typo. I have missed a D, but it's okay. It doesn't matter. That server name is not important to us for now. And this is the most important part: location /. This means the location / means basically any request coming to port 80, apply these configurations to them. So first of all, proxy pass HTTP backend 8080. Now we just learned about how Docker network resolves the IP for us. So in the Docker Compose file, backend is a named microservice. So basically what we are telling here in this nginx configuration file, that any request that comes to port 8080, proxy them into port 8080 of the backend, right? Then there is some redirection of, we are setting host, like, whatever host or whatever was the host from where this request originated, set the same host to this request that is being proxied into the backend. If you don't write this line, what happens is, let's say your request is coming from a particular IP a.b.c.d, and when it reaches the proxy server is now proxying it back into the actual backend framework. So basically for the backend, the host is the proxy, right? But we don't want that to happen, so we are persisting the same host. And similarly, there are other header that we are setting up to make sure that some valuable data is not lost in case you need that later in your code, in a backend code, actually, to be specific. So with that being done, we have an nginx configuration file ready. Now how do we transfer this nginx configuration file from our host into an actual container? So that's being handled by Docker Compose. In the nginx reverse proxy, you will see entry called volumes. Volume is basically something that lets you expose a particular file or a particular directory from your machine into a Docker container. So the left hand side is basically your address of the file in your host machine, which is services/nginx, precisely where the file is present. And then we are going to copy this file or expose this file into etc/nginx/nginx configuration file. Now this is an address that is inside the container. How did I know it? I read the documentation of nginx. And then we are passing something called RO, which is read only. Like, this file cannot be modified by container, it can only be read. If you pass RW, it can be modified, but configuration should not be modified by the container. So it's an RO. And at the last, we have a network, right? So with that being done, let's quickly set up our project now. Now to run a project, to actually start a Django project, all you need to do is write Django admin, start project, and the name of your project. But I don't want to build those files from my installed Python version or the Python on my Mac. I want to build those files from within the container so that these configurations always stay. No matter what, the file is always compiled with the same environment in which it's going to run in production. So instead of running the code directly on my machine, I'll run it from within the virtual environment, and I'll generate the boilerplate code from there. So I'm going to say docker compose run backend shc. Now normally after run backend, you can pass your entire code, but sometimes some string or something gets formatted wrongly and it can throw up an error. So instead of that, just write the sh. Sh is basically, if you are aware about terminals, sh basically stands for the bourne shell of your terminal, the bourne shell. That, like, there is bash, there is bourne, there is zsh or zsh. So we are going to use bourne because this is a Debian based container that we are using. And -c is basically whatever follows next is the command. It's a flag for that. Now within double quotes, we can securely write our code without any worry of any formatting issues, because this is within double string and it will stay as it is. Now I'm going to say Django admin start project. The name of the project is going to be pet adoption. Now this is the first time that I'm running this particular command in this project directory. It's going to build the container for us. Basically, it's going to follow all the instructions in this Docker file, install the packages that are required, get all the dependencies, and get things ready for us. So I'll just speed up this moment for a while. All right. So now the container has been built. Now that the building process has finished, here you can see that a pet adoption folder has been created. So what happened was, our command that we passed, Django admins, start project pet adoption, was basically executed inside the container, and whatever was the output was directly written into our system. And how is that possible? Well, again, Docker Compose, I have basically exposed this entire project directory into the code directory within container. And how do I know that it's code container? Because in Docker file, that's exactly where the code is being stored. Now, it depends upon how you have built your container. Maybe in a later tutorial, I can teach you how a Docker file is written from scratch to create your own microservice. And for this time, I'm going to assume that you are aware of Docker file syntaxes. So from the Docker file, I know that my code is going to be available at code, and my local machine, well, this is where the project is available. So I'm exposing this entire project directory into code, and that's how I'm making sure that the file inside the container and the file on my local machine are synchronized, right? Now let's move on to the next part. Well, also it is a good practice that you create a file called dot, or a hidden file, docker ignore, and in here just pass your env, because you don't want to mix up the environment of your local machine in the environment of your Docker container. This makes sure that this particular file will be ignored, right? Because obviously the whole reason that we are creating the project from within the Docker container is to make sure that our compiled files are different from the installed files or files in the container, right? So with this being done, I'm going to make a couple of changes. So by default, Django, following its own convention, it creates a folder called pet adoption, and within that another folder called pet adoption, which actually has our configurations required for the project. This is to make sure that when the file is created, it's nicely organized in a single directory instead of expanding out or unpacking itself in the entire project directory. But we don't need that, so I'm going to move all those files into the upper project directory itself, like to make sure that these files are not inside any other file, rather it's in the top level project directory. So I move both the files out, and I'm going to delete this pretentious folder which we don't need, right? So we have our pet adoption configurations right here, and we have our manage.py file here, which is again generated by the Django project. We'll use these settings later, we'll come to that later. For now, let's come to pet adoption. So in pet adoption, there is a file called settings.py which was generated by Django. It has all the default configurations of Django, but more often than not, this particular way of using settings.py file is problematic. I'll tell you the reason in a while. I'm going to drag a folder from one of my old projects into here. Now, what I've basically done is I've created a folder called settings, which has a file called init.py inside it. When you write this init.py file inside any directory, Django or Python in general does not look up to that directory as a simple directory anymore. Rather, it's a, how can I say this? This is a module for Django, for Python now. So this is no longer a simple directory. It's a module that Python can import and use within its code, right? Now in here, I have a file called base.py, which has most of the settings that we just saw in the settings.py file, which was created for us. And then I have a local.py file, which is importing all those settings from base. You can see pet adoption.settings.base, pet adoption settings base. It's the local.py file is importing all those settings into itself, and on top of that, it's adding a couple of more settings. Now, why do we need this? Imagine there is your database that you're connecting to when you're developing, where you can test, and when it goes to production, which has the actual real world data, it's different. And it's different in terms of not just the data inside it, but it's also different in terms of scalability, in terms of its efficiency, in terms of its amount of memory it has. It has literally everything different, and probably it's a managed service and not just any simple microservice running on your system, right? So you want to make sure that in local development, your project uses a certain database, and when it goes to production, it uses a separate database, right? So when your code goes to production, what you can do is basically create your own prod.py file, but instead of the default database configuration, you define the config to connect to your prod database. This makes sure that your project is plug and play, right? It goes to production, it uses prod.py configuration, which also imports the base, and when it's in local, it uses the local configurations along with the base. Now, why is base common to everyone? Well, base has those settings which are common. Doesn't matter your code is in production or in development mode right now. And what does base have? Some of the important things that we are actually very concerned about is, first of all, the installed apps array. Installed apps is basically all the applications that are installed within Django. We'll come to this later. Basically, Django makes sure that all your code is independent of each other and self-reusable. So for that, we use something called installed apps in Django, right? This makes sure that most of your code can be reused without even needing to be, it doesn't matter in which project they are present. Think of it that way. And some other settings that matter to us for today is the static URL and static directory, and we'll look in them in a while. And in your local settings, you can see that I have used something called caches, and the cache that I'm using is called a memcached. Memcached is basically a similar software as to Redis. This actually lets you store whatever data you want to cache into your RAM. It has the memcache gets allocated with a certain amount of RAM, and it can use that to cache files according to the need. And now let's just try make sure that our code is running. Now when I write docker compose up, it will basically spin up all the containers which are defined in the compose file. But what is the actual command that starts our server? Well, it's present in this start.sh file. This actual command that starts your code or your backend code is python 3 manage.py. You see manage.py is present here, which points into the settings file of your actual project. And inside that, we are telling the code to run at port 8080. We're telling the backend code that start the server and expose it to port 8080, right? And something that we have skipped here is this important thing called sleep 15. Now, since this is a development machine where we are running the database as a microservice, and this Postgres, it sometimes takes time to boot up, because Postgres is a very fast, efficient, scalable, and slow to get started server, you can say. Once it starts, it's blazing fast, but to get it started, it takes some time. And here, when we start a container, even though in Docker Compose I have defined that the backend code depends upon database, so it makes sure that the backend container is executed or is started only after the database container is up and running. But in terms of container, in terms of Docker Compose, when you say up and running, all that it cares about that the container was booted up. Now, there is a difference between container is booted up and container is usable, because there can be a certain initial configurations or initial sanity checks that needs to be run, and it's not the responsibility of Docker to make sure that your container is in a usable state before any other microservice starts connecting to it or starts reaching out to it in order to get started. Now, that's why something that I'm doing in start.sh file is, instead of booting up the container directly, I am booting it up through the Docker Compose. I'm booting it up through the start.sh file, wherein I'm first sleeping, holding the backend container back for 15 seconds, which is enough time. Now, this is something I found out by hit and trial. 15 works like a charm for me. Maybe it's 10 or 30 for you. It totally depends upon your configuration. Now, it will hold the code from starting for the first 15 seconds, which gives enough time to the database to breathe and get started and be in a usable state. And after that, I'm going to boot up the container. Now, had this been a production database, I would have used my production configuration to start the server. And what's the difference between production server and the development server? Well, Django also has its own web server. Django is a web framework, not a web server. Now, web servers are of two types primarily in Python: WSGI and ASGI, which is basically an asynchronous or the spiritual successor of WSGI. Now, this WSGI configuration is present in your root folder, and there is an WSGI and there is an ASGI. So basically, this WSGI is something that exposes your project into the web server through which it can start accepting HTTP requests. Now, the only difference between WSGI and ASGI is ASGI is asynchronous. It can process concurrently it can process requests, whereas WSGI does it sequentially. But WSGI, trust me, it's fast enough for today's project. Like, we won't see a difference. Now, let's actually start the container and make sure that everything's running, and then we'll jump into the next step. It's probably going to fail this time, and the reason is, we have not told Django where to find the settings, right? Like, by default, Django will look for the settings in whichever section the manage.py files asks it to look for. So by default, it's looking for pet adoption settings, but we know that's not what we are going to use, because our settings are present inside pet adoption settings and then the base local.py. That's what we need to start the code today. So how to do that? Well, come back to Docker Compose. You will see a line that is commented out. Now, the Django settings module is an environment file wherein Django will look for the configurations. And here I'm passing that look for pet adoption settings folder inside that, and then local. That is the configuration that is required to start your container.